Hi, I'm Dougal Watt. I'm the CEO and co-founder of Graph Research Labs. So KGC recently described what we're doing as quietly wild, and that's become my new favorite description. I love that as a description of what we're doing. So just a little bit of background first before I get into the demo. In my career, I've spent decades now architecting systems inside a lot of the world's largest and most complex organizations. And over that time, I've watched the same kind of pattern keep recurring. What we sort of see is that each new system that comes into an organization gets layered onto the last. And then over time, most of the IT budget goes to keeping those old systems running instead of moving the business towards the future that it needs to be moving towards. And I think that's especially accelerated with the advent of AI now. And with AI, we see these organizations, they're racing to layer these AI agents and LLMs on top of the same broken foundation. And they wonder why agents hallucinate and their governance keeps slipping away. So it's a big problem, and it's kind of getting worse, I think. So I started Graph Research Labs because I knew how to solve that problem, and then by doing that, build something quite different. And we use quite a different approach, a quietly wild approach, I think. So our approach is that we define your business once as entities and rules and policies and relationships in an ontology, and that's core to it. And then our GRL engine takes that ontology and generates the entire data stack out of it. So by that, I mean that you get governed agents, AI agents, you get APIs, apps, knowledge graphs, MCP servers, data products. You can get all of that within a few minutes. And that comes from just that one description, and that has full provenance. So a huge advantage of our approach is that when the business and regulations or conditions change, and they're changing all the time, and it's accelerating the change, the data on the data stack can be rebuilt in minutes, and you get full provenance and governance that comes along. And this approach, it's not no code, it's something we call declarative generation. And declarative generation, it's fantastic because it enables us to move a lot faster and more accurately than the world expects, and it lets us redefine what's possible. So we don't have a lot of time in this, so I thought what I'd do is we have a 3-minute demo video that just gives an overview of our platform and how we work, and I'll just play that, and then I'll hand the floor over to everybody. And I'd really like to see what you want to see live, so I can take pieces that specific things you might want to focus on, go in depth into how it works into different tools. So it'd be great if you pop your questions in the chat and ask all those hard questions that people like to ask, and then we'll go deep on it. So let's get into it, and I'll just share that. Has that come through?
Yes.
Yes.
Okay, cool.
Oh, Dougal, the audio is not coming through, but like I think it's fine.
At this point, if the audio is not playing, what I'll do, I'll send you this min and you can stitch it in, but I'll just quickly talk to this piece. So what we've got here is our Ontology Manager, and an Ontology Manager, as it sounds, it manages ontologies. So what it's done here, this is our fire medications management ontology, and it's been created and published out to the rest of our stack, because all of our tools subscribe to, downstream, they subscribe to an ontology. And you can see that it follows standard ontology modeling conventions. So the whole domain of medication management, patients, conditions, encounters, medication codes, all of that's modeled in that ontology. So now what we're going to do next is ingest unstructured data. So the whole platform is designed for structured and unstructured. In this case, we're going to ingest some clinical notes and other documents and add that to our graph. And so this tool now is ingesting streaming data, and it can ingest from any source. It can also ingest batch, bulk. It can be layered across relational databases and do pulling data from relational databases. In this case, it's taking messages from clinical systems, pharmacy systems, ingesting that data, and then pushing it into a graph after it's conformed it to our ontology. So again, the ontology is the single source of truth, and it monitors the whole condition of the pipeline, and it generates provenance data as it's running. And then as all our tools are running, they're reporting back to what we call the governance metagraph. And this tool, it summarizes and aggregates up all of the provenance data flow in the organization. And so it has a running record of all of the ontologies that have been published, the various tools that are creating and consuming data and consuming ontologies, the different users that are using the tools. And it also tracks and manages the provenance view of the data assets, data quality, data contracts, and also any of the other assets that we generate using our generators. And then obviously once you've got data in and you're pushing it out to other sources, you want to be able to analyze the data as well. And because it's in a graph, we built our Insights Explorer. And this tool allows you to create and manage metrics and KPIs on your graph data. And it allows for resolution of variation in different metrics that ultimately drill down to the same underlying metric. And it lets you do question answering over your data as well. So it's a, if you will, a light BI stack on top of your graph data. So now we've taken the ontology and we're subscribing to it in our generator toolset. And this is going to produce the whole range of data assets that we need to take that graph data that we've got into the platform and then expose it to the enterprise. And the value here is that you can effectively build a graph, an entire graph knowledge base, effectively in minutes. And with this set of generator tools, you can go and generate APIs, MCP servers, React apps. You can generate them, and we've got it down to less than a minute now. And so that way you can stitch your graph and integrate it back into all of the existing enterprise technology that you have. But then the really radical thing about this is that as your definition needs to change, your business evolves, the regulatory environment evolves, one modification to the ontology can flow back through this tool and you can regenerate those data assets. So your graph now becomes an important part of the enterprise, but it becomes the part of the enterprise that can evolve the quickest of everything. Okay, so that's a brief introduction to the platform. If anyone's got any questions now, it'd be great to delve into anything you'd like to see. I can show you specific pieces of the platform if you'd like.
So one question from Heather Moore, who couldn't come, but like she left her question. What does getting, adoption by the business or organization look like for you? And Bradley, just like left the question, can you show the workflow at the beginning again, please? And like he will be presenting the demo in New York as well. Yeah.
I'll deal with the first one. So adoption's really one thing we built the generators for is to help to drive that adoption. So I'll incorporate the two questions into one actually. So the workflow, we start with our ontology. So this is the medications ontology. And so we have very standard things like clinical notes. This is an ontology editor, but it's actually an ontology editor that has built-in collaboration and workflow. And the idea is that you achieve consensus around your ontology. In this case, for example, we're managing patients. We might want to, it's linked up to other concepts. So this is our definitive statement of the business of managing patients and medications. And this is actually an ontology we're using with a customer at the moment. So once this ontology is in the required state, it gets published out. You can see that one there, it says published. So from an adoption point of view, what we've seen in healthcare is that there's things that you can do when you have an ontology, excuse me. There are things that you can do when you have an ontology that you can't do with standard technologies. And we've done some very interesting things around privacy data that you can't achieve with standard technologies, about having two-sided, completely anonymous privacy. There's things around medication management, everything designed to accelerate how when a clinician is working with patients, they currently have to spend a lot of time in different systems in a fragmented health system. Everything we're doing in this space is designed to help reduce the burden on the clinicians and get them to encounters and care events where they've got the information that they need as quickly as possible. So from an adoption point of view, from that side, it's about being able to deliver use cases that you simply can't deliver any other way. The privacy work that we're doing, we've done a very extensive search. There's literally nothing like it in the world that, in terms of managing privacy data. So it's about being able to show that there are some unique things that the graph can do that other systems simply can't do. But there's no good having the graph as an island. You need the graph to be able to participate in the rest of the organization. And that's one of the signature innovations that we have. So if we look at this, I've published that ontology. Now I can subscribe to it in this tool. This tool is designed to generate all of the data infrastructure that's required to stitch your graph to integrate your graph into the wider enterprise. So if I bring that ontology on board as part of the workflow, and now I can create an API, so I'll just name it that. And then I can go through, and if we're going to do medication, so I can do all of this sort of thing to connect that to a dispense record, connect that to a medication code. I'll just do a very simple example. Now I can target, I'll just get that ready for processing. So the whole idea is that what I'm doing is I'm taking my graph, which historically is a very separate thing to the rest of enterprise technology, and I'm allowing it to participate in the whole enterprise. I can choose which graph database I target it to. And in this case, I'm going to generate an API so anybody in the enterprise can write against my graph, and they just use totally standard technology. They don't know they're using a graph. So the barrier to adoption, back to Heather's question, the barrier to adoption is effectively now zero. So the entire current development team in the organization, they could just write against this graph. They can integrate it into their workflow. They can integrate it with other technology, and then they just keep working. Likewise, we can generate a React app. And that creates the whole transactional core of the app. So a standard developer can run with that, and they can build whatever they want on top of it. And again, they don't know it's a graph that they're transacting with. And we can also allow LLMs to be able to work with that data as well, because we generate an MCP server. And what that ultimately looks like, so I've deployed one earlier. I'll just, I'll have a look at this here. And so you just get completely standardized APIs and React apps and so forth. So that's from, I started at this point here. I created my ontology. I published it out. It can also participate here. So if I want to bring data into my graph, so we cover that whole life cycle from defining your business in that ontology, being able to ingest data through various technologies, and then being able to analyze and then repurpose and then publish the data out to the rest of the enterprise.
That is amazing. It's like really facing the enterprise clients, and I can see like how this will be really like well adopted. And that, oh, and also, you know, you'll be presenting the demo in New York, but like, do you think, you know, do you want to share some things that what you are gonna be like demoing in person, like, you know, something different will there be in person?
So I'm doing the workshop on the Tuesday, and the workshop is on using AI to assist in the modeling process and the issues around AI safety and governance and control. We have two other products that I'm not showing here that are designed to, one is from an architecture perspective. So what we're seeing is AI is being rolled out across organizations. It's just huge, but a lot of times it doesn't really deliver the degree of accuracy and the degree of control that organizations want. And I think there's at least two elements to that. The first is that you've got to have good, clean, quality data. And so these tools I showed you here, they're all about being able to create and manage that life cycle so that you get good, clean, quality data. And out the back of that, you can do really interesting things, like I mentioned, in, for example, healthcare, defense, environment, engineering, all sorts of use cases. Because you can join all that disparate data together, you can drive use cases that you couldn't do before. So that's one side of the equation. The second side of the equation is that to work really effectively, AI needs to be given that clean data, but it needs to be given the right schema. So it really is working from your data, remembering that they're not trained on your data, but they also need the schema, the business definition of your organization, because they're not trained on that either. And we've done experiments where you can effectively take, you know, from sort of 50-60% successful response all the way into the sort of the mid-90s for having AI respond correctly to, you know, when it's asked to do things. And so we've built two products. One is a semantic agent harness, and what it does is it also reads in the ontology, and then it acts as a harness around AI. So as you run an agent, that AI is running in a controlled way. It's got access to that ontology as a schema. So if you ask it a question about something from here, if you ask it a question about, okay, well, tell me about a clinical note, for example, or I ask it for, tell me about an encounter for this patient with this cohort for this date and time, it's not going to go and hallucinate because it's got access to all of the information that it needs to know. And that agent harness, if you will, it wraps the agent as it runs, and it does a whole range of very interesting things, like when the agent makes decisions, when it has to share data with other agents, when it has to be audited, because in highly regulatory environments like defense or healthcare, you know, you really need, or banking is a great example too. We're doing some work in that space. When they're running in that world, you have to be, if a regulator comes to say, hey, look, explain how that agent came to that conclusion, you have to be able to say how it did it. And at the moment, that's actually impossible. So we built this harness so that the activities of the agent can be constrained if they need to be, but they can also be audited and the provenance tracked. And increasingly, I mean, I think those of us that use agents, we will do this. We might run 5 or 6 or 10, and we might be working in a team, and each team member is running several, and they need to be able to collaborate. And that's actually really difficult to do. So we built the harness so that you have a local memory and you have local context, but you can share that context through a project. And then the other product that we built in that space is for enterprise architecture. And that's probably more an organization that's a bit larger, say like a bank. but they have a set of things. They have patterns and guardrails that they want teams to follow. And so we turned it into something programmatic. So it's a parallel harness that runs as well. You can run them both at once if you want to do it. And the architecture intelligence graph, its job is to say, hey, look, agent, here are some guardrails that we want you to follow. And if you make any decisions that are important, you need to commit those in. So you just need to tell us. And then it gets updated into the agent repository for your architecture. So instead of being static documents, your enterprise architecture becomes something computational and that agents participate in.
Amazing. Was that also like including the answer to what Deb just asked, like clinical notes unstructured text, right?
What was that one, sorry?
Okay. Yeah, like Deb, there's another question from Deb, like she's asking, are clinical notes unstructured text?
They are considered unstructured because typically if you look at one, it would be in a PDF, and it might be an HTML, excuse me, it might be text, and those sort of documents, they're effectively dead data, and we need to be able to bring them into the organization. So the way we do that is this product has a set of, I'll just find the project. This product allows you to ingest those, I'll take that one, ingest those files and run different types of extractors over it. So I've got a configuration here, and it's using things like named entity recognition and keyword extraction, and it's working off the ontology. You can also connect an LLM. So what it's doing is it's loading in that document. In this case, I'll run a few. It's got some PDFs and HTML. And what it's doing is it's pulling out all the kinds of entities that it can find and the relationships that it can find inside that data. So it's worked out some categories and so forth. And then I can choose to do a number of things with that. So what I've done is I've taken something that's on a file system that's really, it might have some internal structure, but it's not conformed in any way to a schema. And this has historically been the problem. You've got structured data, you've got graph data, which is great because it's got relationships, but all of that dead data that sits in PDFs and whatever, that could not participate in the organization. Now we can stitch the whole thing together. And while we do it, we can also track the provenance. So in this case, you can see it's pulled out something from a clinical note. It used named entity extraction to do it, recognition. It's pulled out 62 entities. And in this case, it's used keyword, and it's also got some relationships. So this dead data now is part of our graph. And what we've done, this is something unique that we do too. When you run that data, you don't necessarily always trust it. So you drop it into what we call a provisional data store first. And then you can run some machine learning on that, or an LLM as well, or a human can inspect it. And when you're happy, you can promote it into your transactional graph. And that way you've got this sort of guardrail and gate and control, so that as the data flows in, you can just set some sort of controls over it before it gets into live and into production. So you can just be sure that it's quality data.
That's amazing. That's amazing. And next question, we have 3 more questions to go. Yeah, like amazing. How automated can the ontology generation be? Could LLMs be leveraged there as well?
Absolutely. And that's what my workshop on Tuesday is talking about. So they absolutely can be, but I think with anything LLM, we have to be mindful that it's kind of 80-20 rule. It can maybe get you 80% of there, but it does need a human to oversight it, because there's a bunch of anti-patterns, if you will, that LLMs create when they make an ontology. So you just have to work out, these are the things that the LLM was good at doing, and these are the things that it's not very good at doing. And then that's where the human comes in. So the human starts it off, guides it, provides enough context for it to operate correctly. And then when it spits a result out at the end, the human curates that result. And that's a really important step.
Amazing. And Deb left one more question. How does it deal with repetitive data included in US electronic health records?
Yeah, so often there are duplicates. I guess that's what the question's talking to, the sort of duplication of data. And so we have systems to, even at ingest time here, when it's running an extraction configuration, it can do things like we can do tasks to disambiguate and say if I run a clinical note extraction and I run a PDF for maybe some clinical guidelines and there's some entities that are in common, we can choose to actually land that in a provisional graph and keep it, because there might be subtle differences we're not aware of. But if we also have part of the tooling can say, well, these actually are exactly the same thing, and I'm just going to store it once. But if I bring across another document and it's got the same entities, but there's additional relationships, we can also do that as well. So we can link that together. So yeah, there's options in there around how you do the disambiguation, if you will, and the things that are common.
Got it. Thank you. And the last question from Feng Liang is, it seems like there's a hierarchy structure for managing classes where each node maps to a graph-based ontology. How do these two concepts work together? Does all sub-ontology graph forms a broader ontology graph? Great question.
So if I understand that, is that talking about imports? So I can actually add import here, so I can go and pull that ontology, or I can actually load it. So the tool Ontology Manager allows you to have structured, layered ontologies. This one here, this one here, you can see it's actually importing gist. So this is a full ontology we have a product with our semantic agent harness in banking. We have a set of compliance accelerator packs, and the idea there is that banks are subject to a lot of different regulations, and so we have pre-built ontologies, 3 layers of ontologies, so that the bank doesn't have to go and do that modeling. All they have to do is, when they ingest the ontology, is go through and their policies and controls, which are typically unstructured documents, and import those into the graph and link them to the ontology. But the ontology itself is built up of layers. So there's an upper ontology at the top. In this case, it's just. Then below that, in the middle layer, is this ontology, which is regulation and compliance. And then the accelerator pack is linked into this. So it's a hierarchy of ontologies, which I think was the question.
All right. Is there any other questions from the audience, guys? I mean, there was like a lot of questions there. So yeah, guys, thank you all for dropping your questions. And Dougal, thank you so much. Really appreciate you walking us through this live. And this is making us more exciting about your workshop in KGC in person. So yeah, I think this is gonna be like spark a lot of conversations at the conference as well. Thank you so much for your time. And I think that's a wrap on today's KGC Demo Day. Big thanks to Dougal and the Graph Research Labs team. This is exactly the kind of like production grade content we want to keep doing in this community. So yeah, guys, I think we can conclude our Demo Day like this. And then, a few things before you go. KGC 2026, New York, May 4th to 8th. And there are also virtual links too. So please, RSVP to the virtual if you cannot make it to New York. And Dougal, if there's any, links you want to share to the audience, LinkedIn or, the landing page link, feel free to also drop it on the chat so people can follow you up, after this.
Great, thank you. Yeah, hey, thanks everybody. It's really great to be able to show what we're doing, and come and if this sort of connects to a problem you're working on, come and see me at KGC next week, or just drop me a note. Happy to talk and share what we're doing and see if we can help in any way.
Yeah, all right. Thank you guys. And yeah, that's a wrap for today.
Okay.
We will be uploading the videos, full videos on YouTube, so stay tuned.